Hi friends, here we have to convert this number 1982 from base 10 to base 12. Right. So base 10 is the regular base that we use. What is this base notation? Base notation is very simple. Base notation is something like this. For example, if we take any number, let's take this 1982 only. What is 1982? 1982 is 1 into 1000, which is 10 cube, plus 9 into 100, which is 10 square, plus 8 into 10, which is 10 power n, plus 2 into 1, which is 10 power 0. Right. So all four digits are actually multiplications of 10 cube, 10 square, 10, and 10 power 0, which is 1. Right. So that's how we arrive at 1982. 1000 plus 900 plus 80 plus 2. That is base 10 notation. We default use all base 10 notation. We simply write 236. That means 2 into 10 square plus 3 into 10 plus 6. We directly write it like this. 6 into 10 power 0. We directly write like this because it is base 10. It is very easy. Now, same for base 12. 236, if you have to write it as base 12, then this becomes, substitute we put 12, then it is 2 into 12 square plus 3 into 12 plus 6. Whatever is this number, that is actually base 12 notation. Or in fact, it is base 2 notation. Base 2 means binary digits, binary decimals, right? We see only 1, 0, 0, 1, 1, 1, etc. These kind of numbers, right? This is binary notation. Binary notation is 1 into, so the last one is again 1, 1 plus 2 into 1, plus 2 square into 0, plus 2 cube into 1. Right, 1, 0, 1, 1. So this is binary notation. So here we are given to convert this number. What is this number? This number 1982. We are given a number 1982. We have to write in such a form that a into 12 cube plus b into 12 square plus c into 12 plus d is actually equal to 1982. This is what we have to write. Now there are two ways of approaching this. One way is, what is this 12 cube, what is 12 square, what is 12, and what is this one? Let's try to split it like this. 1982. If you remove 12 cube, right? If you remove 12 cube, then we'll be left with 254. 254 in 12 square, it is again 112 square only. So 144 if you remove, then it is 110. 110, 9 twelves is 108, so we'll be left with 2. So basically what we are saying, 12 cube will go once, 12 square will go once, 12 will go 9 times, and remaining is 2. That is equal to saying 1 into 12 cube plus 12 square. In the remaining part, 12 square is going only once, so 1 into 12 square. In the remaining part, after 12 square has gone, in that remaining part, 12 is going 9 times, 9 twelves, 108. And in the remaining part, 2, that is the remainder. 12 will go 0 times and 2 will be left. Right? So we can write it like this. But this is cumbersome. Every time remembering all cubes and power fours, etc. for all numbers is actually very difficult. There is a luckily an easier way. What is that easier way? Just write it like this simply. 1982, we will just divide it by 12. So we'll continue dividing by 12. For example, 1982 by 12, we'll write it as 165. 165 into 12 is 1980. Right? 165. We are doing just division by 12. 165 and just writing the remainder. What is the remainder? 165 into 12, it is 1980 plus remainder is 2. Now take this 165 and again divide by 12. Right? 12 13s is 156 plus 9 is 165. Then remainder is 9. So then again 12 ones plus 1 is 13. 12 zeros plus 1 is this one. So we just go on dividing the given number by 12. Because the base notation we want is about 12. If it is about 5, then we'll keep on dividing fives. Or if it is 13, we keep on dividing 13s. Basically, 1982 we are writing as 12 into 165 plus 2. Right, 12 times 165 and a remainder 2 means 12 times 165 plus 2. Then let's take this part. this 165 is 12 times 13 plus 9. That is what we have done. 165, 12 is going 13 next and 9 is the remainder. Right, this 13 again will take, 13 is 12 times 1 plus 1. Right, this 1 again will take 12 times 0 plus 1. What are these four numbers that we are getting, right? Going from bottom to up. 1192. This is base 12 notation. This is base 12 number. This is the base 1. 1982 in base 10 is equal to 1192 in base 12. Obviously, base 12 number will look smaller than base 10. Why? Because it is 1 into 12 power 0, 1, 2, 3, 12 cube. 12 cube plus 1 into 12 square plus 1 into 12 plus 2. Right. If it was base 10, obviously then 1 into 10 cube plus whatever, that becomes 1192. Obviously, 1192 in base 12 is much bigger. It should be bigger than 1192 of base 10. 1192 of base 10 means 1192 only. So, in base 10, if this is converted, it is actually 1982. So, if given two numbers which are looking same in two different bases, obviously the bigger base number is actually higher. Right. So now we have given this notation, right? This way of doing. Here we have to divide it only by 12. We don't need to remember 12 square, 12 cube, 12 power 4, whatever. But will this give the same representation as this or not? A into 12 cube plus B into 12 square plus C into 12 plus D. How do you know? So let us rephrase this again. So 13 is 12 into 1 plus 1. That is basically 12 plus 1. Let us insert this 12 plus 1 here. Then what will happen? 12 into 12 plus 1 plus 9. What is that? 12 square plus 12 plus 9. What is this? 12 square plus 12 plus 9 is actually 165. Let us insert this here. 12 into 165 plus 2, right? This part, whatever this one in 65, let us put that here. So 12 into 12 square plus 12 plus 9 plus 2. That becomes 12 cube plus 12 square plus 12 into 9 or 9 into 12 plus 2, which is like this, right? 12 cube, 12 square, 12 plus this thing. A, B, C, D. A, B, C, D. Right. So that's why this is giving this exact representation 1192, whether you do it this way or do it this way, it is giving the same representation, right? This is just an easier way of doing uh, base conversion between any bases, be it 12, be it 2, be it 8, whatever, right? Yes, just we keep on dividing, and whatever question that we are getting and the remainder that we are getting, we just keep them, right? Guys, it's such a simple problem. We just need to know how to do the conversion. I think this kind of problem has come again in CAT in some other year. We'll get there also. Thank you, guys.